So, I think we shall start now. Good evening, everyone. Myself Chinmoyi, a PMRF scholar from IIT Madras. So, we shall start now. So, I hope my screen is visible, right? And I'm clearly audible. So, can you reply, please? Am I audible or my screen is visible and not? Okay. So, this
Yes,
advanced,
ma'am. Visible and
yes.
audible, ma'am.
Okay, thank you.
Thank you.
So this advanced machining process is instructed by Professor Manas Das from IIT Guwahati and myself Chinmoy Datta, a PMRF scholar from IIT Madras. So like today's assignment 4 is based on magnetorheological abrasive flow finishing process. So in previous week we have seen some questions and assignments on abrasive flow finishing process. Okay, so here basically what happens, first we need to understand what is, just a minute. So basically we need to first understand what is, like I'll briefly, though those are they are in lectures, but I'll briefly tell about the process and then I'll go to assignment questions. So like first of all you need to understand what is magnetorheological finishing process, or like what is magnetorheological fluid itself. So that magnetorheological fluid actually it's a type, we can say, of smart material. So whose rheological properties, basically what is rheological properties, example we can say viscosity, shear stress, those properties are rheological properties of material and those can be rapidly varied, like if we apply magnetic field in this material. Okay, so we can say it is a free flowing liquid state which in the absence of magnetic field, while its viscosity increase on the application of magnetic field. When magnetic field is applied, that time itself viscosity changes. So we can say by applying viscosity itself, like by applying magnetic field, the viscosity can be increased in that material, those materials. That magnetorheological fluid can be controlled actually, so basically increased or decreased. So with that strength, we can say, of that magnetic field which are applied to that material. Okay, so that magnetorheological fluid actually shifts. We can see even this nature in these materials, like it can be shifted from solid to liquid state, and also that around quite quickly, that too from liquid to solid. Okay, so that like helps actually in making that flexible actually in this material, so that those allows actually to adapt with any external forces. So if any external forces are applied or magnetic field are applied, actually viscosity and all rheological properties we can vary in this rheological fluid. Okay, so that technology actually proven for many industrial applications we have seen, like hydraulic systems in actuators. We have seen those materials applications in automotive industries itself, or like that seismic production or say shock absorbers. We have seen a wide application of that magnetorheological fluid. So actually its main benefit is that state change, as I have told, like that from liquid to solid, solid to liquid, that state change and that response, and within millisecond it changes from one state to another state. Okay, so that's the main importance, or main, we can say, significance of that rheological magnetorheological fluid. Okay, so we'll see like how that fluid, or how that machining process, finishing magnetorheological finishing process works. So I'll briefly tell about that. So that process actually works with that magnetorheological fluid, which actually consists of that magnetic particles, or say polishing agents and water. So that fluid actually continuously applied to that rotating wheel, which will just a minute, someone wants to join. So that actually that magnetorheological fluid, or MR fluid. So that MR fluid, which consists of that magnetic particles and that polishing agents and water, that fluid actually applied to the rotating wheel via a nozzle. Okay, then that wheel surface, below that wheel surface, actually a magnet is there, which basically that magnet only generates that magnetic field. So that magnetic field only changes that viscosity and rheological property, which I have discussed right now. So that like intelligent fluid, it turns into that. Okay, so that the like So, like that magnetological fluid and that magnet, actually magnet particles, that polishing agents and that water, actually together applied to that nozzle, to that wheel via nozzle, and then that below that wheel surface one magnet is there, which generates that magnetic field. Okay, and that magnetic field changes that viscosity, so that that iron particles are there, those align and form a like stiff structure in that wheel. So water, like some abrasive particles are there that concentrate as solidified. Okay, that thin which is there, right, polishing layer, or that due to that polishing agents on the surface. So that workpiece is actually clamped, or we can say move near to the movable holder and dipped into that polishing layer on that surface to be machined. So polishing of that workpiece surface begins that the lowest, like that position of that workpiece, which is to be machined, that can be actually positioned fully automatically. Nowadays it actually fully automatic way it is positioned to like save the computational operational time. Okay, so that targeted material actually removal that enables that local correction of that shape errors. So in this way the whole magnetorheological finishing process is actually basically works. And in that previous class, abrasive flow finishing, about that abrasive flow finishing process, we have seen that how abrasive flow finishing process occurs. Like with the help of abrasive particles is actually with the abrasive laden medium, it's there to due to that abrasive flows that like workpiece materials are removed, and finally it's finished that the material workpiece material. Okay, so abrasive flow finishing process also we have seen. So by combining both the MRF, like magnetorheological finishing process, and abrasive flow finishing process, MRAFF, magnetorheological abrasive flow finishing process, has been introduced in this machining process. Okay, so basically like in that magnetorheological abrasive flow finishing process, or MRAF process, actually provides better control over that rheological properties like viscosity, shear stress, those properties of abrasives in that finishing medium. Okay, so that magnetorheological polishing fluids, actually we can say those fluids are the example, basic example of this carbonyl iron powder, silicon carbide abrasives, which actually dispersed in that viscoplastic base of grease or some mineral oil. Those are additives. Actually, we'll see in later slides that those are the additives which are used in that process. What say for example, grease, mineral oil, or some surfactants, then silica, grease, those are used, and then actually it changes in rheological behavior in that presence of magnetic field. Okay, so that's overall we can say that the smart behavior of MR fluid actually used in this process, which is even precisely controlled, okay, in that finishing process. So finally we'll get a like fine or well surface finish. So this is the main aim of that, combining those two process and to build one unique process as MRAFF, that is magnetorheological abrasive flow finishing process. Okay, so from the figure itself, we can see like that experimental setup of this MRAF process. So that hydraulically powered that experimental setup actually is designed to see that process characteristics and performance of this process itself. So it consists of obviously that MR polishing, that magnetorheological polishing fluid cylinders. Okay, then hydraulic actuators will be there, then electromagnet fixtures and supporting frames will be there. So like actually in that machine experiments were conducted, like in past on that say for example stainless steel, they have performed the experiments actually. So in different magnetic field strength, it was like perform experiments was performed actually to observe itself that its effect on that final surface finish. Okay, so but like surface finish, they didn't actually see that much of changes in surface roughness which was observed like at finishing process. So that in MRFF process, that actually MRFF is extruded through the workpiece passage, which will be finished utilizing two opposite cast iron cylinders where that fluids are there. Okay, and those are under the presence of external magnetic fields. So we have seen in like magnetorheological fluid, right, what is the effect on magnetic field. So under the presence of that magnetic field itself, those two opposed like cast iron cylinders are there full of MR fluids. Okay, then that viscosity of that magnetorheological polishing fluids actually is nothing but a function actually of magnetic field strength, and actually it varies according to that finishing characteristics. So that actually we know about Bingham plastic polishing fluid. Okay, say actually you know even that what is Bingham plastic, which acts rigid at lower stress and higher stress, it will act as a fluid. So basically actually this property or this behavior actually it follows that shearing of that Bingham plastic polishing fluid near that workpiece surface, that actually contributes to that material removal. So in this process, basically whatever the material removal takes place and that finishing process takes place, it's just because of that shearing of that Bingham plastic polishing fluid, and that too near the workpiece surface region. Okay, so that extrusion of that MRF fluids through that passage which is formed in that workpiece fixture, actually it's like we can say it's accomplished by that driving two opposed pistons which I have discussed in that cylinders using that hydraulic actuators. Okay, which is operated in desired manner with that like with here one hydraulic circuits, we can say that hydraulic, with the help of that hydraulic circuits itself it works. So that setup actually consists of cylinders, pistons, workpiece fixtures, electromagnet hydraulic drives, and then controllers, and then that supporting frame. Okay, so those are there in the pictures itself. So basically in MRFF process, that magnetically stiffened slug of that magnetorheological fluid extruded, and then like back and forth motion is going on that process through or that across that passage which is formed by the workpiece and that workpiece fixture. Okay, so that extrusion is done by basically back and forth motion. So that abrasion occurs actually due to this, and selectively only where that their magnetic field is applied. So external magnetic field is applied, I have said. So only in this region itself abrasion is occurring across that workpiece surfaces, and other portions will be unaffected. Okay, that rheological behavior of that polishing fluid changes from nearly, like we can say, Newtonian to Bingham plastic wood. We know that nature of that Bingham plastic, so accordingly actually it behaves, and that even like vice versa it will effect on that whole process. Okay, it actually based on that, and like entering and exiting the like when it will enter and when it will exit that finishing zone, actually it will be dependent upon. Okay, that that abrasive, like which we have like discussed, that abrasive held by that carbonyl iron chains which rubs the workpiece surfaces, that and then shears like shear the peaks like from it. Okay, then that amount of that materials which is sheared from the peaks of the workpiece surface, which will be occurring that like that material which is sheared, which actually occurs by the abrasive grains. So this actually depends basically on the bonding strength which will be created between that field structure of that MR fluid and the extrusion pressure which will be applied through the piston in the whole machining, in that machining process. When piston is there, through that extrusion pressure is going applying. So in between that field created, in that bonding strength actually there, that bonding strength is affecting that material, shearing out of that material. Okay, so in this whole way that magnetic field strength actually controls that we can say that extent of that abrasion of peaks by that abrasive particles. Okay, okay, moving to that first question, which property of magnetorheological polishing medium can be manipulated externally? So, as I have discussed right now, like that rheological properties include viscosity, shear stress, those parameters, okay, those properties. So, we have seen in that working principle itself, by giving externally magnetic field or by applying externally magnetic field, that viscosity can be changed from, like it can be varied or it can be increased or it can be decreased. So, the question is given as which property of magnet. Okay, so which property of magnetorheological polishing medium can be manipulated externally? So this will be, the right answer will be viscosity, isn't it? So, and the second question is given as users. So users of this process from industrial aspect, dies and molds manufacturing, automobile industries, semiconductor industries. Actually, in industry, that MRAFF process is basically used in automobile industries, semiconductor industries, even in medical industries itself, like medical instruments itself, say hip joints, knee joints, also in making that finishing or polishing process, this method is used actually. So the answer will be all of the above actually. Okay. Next, moving to the question number 3. Indentation by the abrasive particles occurs due to that. Okay. So, first of all, like we like the forces, effect of the forces, if we have to say, like due in like rotational, to overcome the like limitations in occurred in that magnetorheological abrasive flow finishing process, the rotational magnetorheological flow finishing processes are used actually basically. So in that rotational magnetorheological flow finishing process, that due to that reciprocation, so one radial force and as well as one axial force is generated in that RMRFF process. Okay, so and that actually along with that one magnetic force is also. So along with that, one magnetic force is also there. So that actually so what will be the forces due to that reciprocation? One will be the radial force, one will be the axial force, and also that due to that magnetic field, magnetic force is also there. So direction of that magnetic force and the radial force actually in same direction itself. Okay, so for both those both forces will be in same direction, and that magnetic force which is there, that will be the perpendicular to the workpiece direction. Okay, so actually that the fluid which rotates at same rpm as magnet rotates. Okay, there is a uniformity between that rotations, that in same rotation the fluid will be rotated as well as at same rpm that magnet will be also rotated. So that indentation force actually are the total summation force of that magnetic plus radial plus centrifugal force. So we can say that combined effect of magnetic force plus centrifugal force occurs, which like due to which indentation occurs by that abrasive particles. Okay, and one more thing, like we have to know that the cutting force actually is also there, which will be the resultant force of that axial force and tangential forces. So actually that effect of that forces are playing an important role in like shearing like in indenting the like materials from the workpiece surface by the abrasive particles, that in which direction or which way, due to that which force the workpiece materials are shearing out, like by that abrasive, with the help of abrasive particles. So in rotational rotational magnetorheological abrasive flow finishing process, basically combined effect occurs, happens due to that magnetic field, magnetic force plus centrifugal force. So that right answer will be that combined effect of both. Okay, moving to that question number 4. The path followed by the abrasive grains in uh, rotational magnetorheological abrasive flow finishing are. So basically what happens in magnetorheological flow finishing process, actually just a minute, we'll move into, see they are abrasive in the figure like of MRAFF process. Basically that abrasive particles actually traverse along the linear path. Okay, actually it follows the linear path, and but like when we use that rotational magnetorheological abrasive flow finishing process, their abrasive particles will be traversing in certain circular path. Actually it follows the circular path to traverse, but like at the same time we'll notice that due to that reciprocation motion in that rotational magnetorheological abrasive flow finishing process, Actually, those follows that helical path. Actually, this abrasive particle starts following a helical path. Okay, and due to that, we have seen that area actually covered by a single particle actually is more in that MRFF process compared to that MRFF process, because in MRFF process abrasive particles follow single abrasive particles follow a simple linear path, whereas that in rotational MRFF process. So in MRFF process, what I was saying, like that abrasive particles, every single abrasive particles follow a linear path. But in case of our MRFF process, every single abrasive particles follow an helical path. So that area actually will be covered more in case of our MRFF process by the abrasive particles. Okay, so the question is given as path followed by abrasive grains in our MRFF process are linear, helical, circular or none. So the right answer will be helical. Okay, so linear will be for MRAFF process. Okay. So the next question is more interaction of abrasive particles and workpiece surface in RMFF due to longer traverse rate by abrasive, short traverse length by abrasive and none. Okay, so right now itself we have seen that in RMFF process the like abrasive particles follow helical path. So as that abrasive particles follow that helical path, actually that abrasive particles will get more time to interact with the workpiece surface. So in that case, the material removal also takes in a good manner, so that surface finishing also and material surface finishing process is also happened in a good way, or that will get a well surface finish. Okay, because it will get more time to interact with the workpiece surfaces. So the right answer will be more interaction of abrasive particles and workpiece surfaces in our MRFF due to longer traverse length by abrasives. Okay, this will be the right answer. Now we are like we have to know few properties of MR fluids actually. Those are the properties. As we have seen, carbonyl powders are there which are used as MR fluid. So those are the properties of that MR fluids, where yield strength will be in between in the range 0 to 100 kPa. You may get one assignment question in your assignments that what will be the range of yield strength. So you have to answer that 0 to 100 kilopascal. Okay. So the range of operating temperature will be minus 40 to 150 degrees Celsius, and the specific gravity range will be 3 to 4. Okay, so you have to remember the properties of that MR fluid. So here one question is given as specific gravity of MR fluids are in the range of 1 to 2, 2 to 3 and 3 to 4. Obviously the right answer will be 3 to 4. Okay, so basically in that process additives are used, we have seen in the first slide itself. So additives are used in MR fluids. So actually that's MR fluids, that additives which are used as silica, surfactants, grease, mineral oils, and like some oleic acid or like that. So what are actually why those additives are used? Actually those additives are used in MR fluid for enhancing that redispersibility and to achieve the stability of that fluid. particles. Okay, so as we know that for an additives are using like used for so as we have seen like why additives are used in amorphate, because it enhances that redispersibility and also it enhances or achieves that stability actually. So the first option to enhance redispersibility to achieve instability and none. So the right option will be to enhance redispersibility. Okay, and moving to the next question. So with with increasing volume ratio of CIP by SIC, our delta RA means that reduction percentage of that reduction rate in RA will increase, decrease, first increase then decrease. So actually if we denote x axis as volume ratio V and VL volume ratio and y axis as delta RA, percentage of delta RA. Okay, we'll see this kind of graph. So basically what happens while increasing that volume ratio first of CIP and SIC, that abrasive particles will be like strong, more strong, and it will hit like the workpiece materials, and a huge amount of material removes and the surface finishing will be improving, and that RA will be that percentage of that surface roughness value also will be increasing with the increasing in volume ratio of CIP by SIC. Okay, because that time abrasive particles will be more and it will be very strong. But when it reaches to that optimal level, actually it will be more. It will be increasing with that increasing in volume ratio. After that, it will start decreasing with increasing in volume ratio, that RA value. Why? Because that time abrasive number of abrasive particles will be less, and it will not like that bonding strength will be very less to even polish the material. Actually, it will not be possible to be polishing to be happen actually in that range, because due to the weak abrasive particles or less number of abrasive particles. Okay, so at that time with increasing of volume, so at that time with increasing in volume ratio of CIP by SIC, the roughness value will be decreasing. Okay, same we can see in extrusion pressure also itself. With increasing in extruded pressure, that RA value will be first increasing, and then after reaching at optimum level, it will be decreasing. It will start decreasing with increasing extruded pressure. Okay, so you can see the effect like effects on various process parameters on material removal rate and surface finishing process from the lectures, and accordingly like you'll get some questions on assignments based on that itself. So what are the effects on the RA value with the process parameters. Okay, so the right answer will be for this is first increase and then decreases. Okay, so who came late, for those people. Like you can see the assignment questions and you can refer the assignment questions, and by referring those assignment questions you can answer this year assignments. Actually, the first question is given as which property of magnetorheological polishing medium can be manipulated externally. That answer will be viscosity, because that we have seen that rheological property is as viscosity, shear stress. Among them, viscosity can be varied with the change with by applying magnetic field externally. Okay, so the right answer will be viscosity. And the second question, uses of this process. Actually, the application of that MRAFF process in industry. Where are the applications? In dyes and molds manufacturing, automobile industries, semiconductor industries, biomedical industries. Okay, and then the third question was that indentation by that abrasive particles occur due to which will be combined effect of centrifugal forces, that is radial force, axial force and magnetic force together. Okay, and that in rotational magnetorheological abrasive flow finishing process, abrasive grains follows the path which path it follows, helical path it follows actually, and linear path, like in MRFF process, linear it for abrasive grains are following linear path. Okay, so like due to that helical path, actually it gets longer actually a high time to interact to the workpiece surface, so longer, due to that longer traverse length by the abrasives, and the specific gravity of that fluids are in the range of 3 to 4. So the additives are used in MR fluid to enhance the redispersibility. And here we have seen the effect of process parameters on RA. Okay, any confusion in these questions, or let me check. Okay, someone asked question viscosity. Okay, even I have answered it in previous class itself to you, that what is viscosity. It will be the, yeah, it's correctly said, it will be the measure of fluid's resistance to that flow. So any other questions? So if anyone having any questions or doubts, you can send me mail to this, to my mail ID itself. If you are having any doubt in that process, machining process which I have discussed today.
Okay, ma'am.
If one in, okay, no more questions. Okay, so any doubt, or else we can stop. So shall we close the meeting? You can see this who have joined later. You can see the answers of the assignments questions. In, you can refer to solve your question answers. So those are the answers of the questions and the explanation. Okay, any doubt? Shall we close the meeting?
Yes, ma'am.
Okay, thank you.